I was a regular AM or amplitude modulation operator in the initial days of my ham radio activity. Started by adding a modulator to the 7-watt VU to VWN QRP with BD139 RF final and TBA810 IC audio amplifier. Later I moved on to 3x807 vacuum tube radio with 120 watt DC input. If I remember correctly, I was using screen modulation with a solid state audio amplifier. Though plate modulation would have been better, that would have needed a powerful audio amplifier which I did not have. While I could get only local contacts on AM with QRP setup, I could get an occasional DX contact from Indonesia on AM with the latter setup. A few months back, I could hear VU3IZD from Thiruvananthapuram using VU to VWN QRP along with a 25 watt push-pull linear amplifier, both homebrew. Though some of my friends could copy him 5 and 9 on 7055 kHz, I could hardly know that he was transmitting. So I have not tried AM with my FT710, which incidentally can give only 25 watts on AM, though the peak envelope power on SSB or single side band is 100 watts. There is a lot of discussion on AM on the QRZ forum with a lot of enthusiasm, probably because of the better audio quality on AM. SSB signals may occupy only about 3 kHz bandwidth, while AM with a carrier and 2 sidebands can occupy up to 10 kHz of bandwidth. I can see that there is provision for a narrow band AM/N in my radio, which also I have never tried. Higher noise level these days due to innumerable consumer devices around pumping RF into the air, AM seems to be a difficult option for me currently. In the US, it seems AM activity is around 29 MHz in the 10 meter band and in upper part of the 80 meter band, 75 meter, which we do not have access in India. There is one situation where AM still rules in the world of communication. That is air traffic control, where aircraft to control tower traffic is invariably on AM with definite reasons. On FM, the FM capture effect would override weak signals and emergency breakthrough communication from an aircraft in distress may not be possible when a channel is in use by a stronger station. In case of SSB, with requirement for more precise tuning, Doppler shift from a fast-moving aircraft may detune the signal, though the speed of an aircraft is only a small fraction of the speed of electromagnetic waves. You may be aware that Doppler shift does shift signals up to 10 kHz on UHF in case of low Earth orbit satellites like International Space Station, which are moving about 15 times faster than conventional aircrafts.